Okay, so a warm welcome back, everybody. We've come to the last session in our two-day marathon, the 2021 D3 Drug Discovery, Development and Diagnostics. We've had a wonderful journey all the way through. I don't know if any of you caught the last session just now on the advances in digital diagnostics and what that actually means in terms of the data vistas that have been opened up, the impact to leveraging political will towards evidence-based policy making. That's back in fashion, I've heard at the moment. And then also the potential to redesign, reimagine the financial incentives around diagnostics for Africa, as an example used in that particular session. Absolutely amazing opportunities opening up when we go down that road. And I think that's a wonderful segue into this final session. As you know, we had today's opening session of the WHO's Essential Diagnostics List. We went through that and we went into a focus on access in Kenya, actually, for visceral leishmaniasis, and then schistosomosis in terms of the impact of modeling to that, and then how it's being used in the clinical management of treated patients. Beyond that, we looked at innovation, so CRISPR, an alternative to the PCR in terms of using the field requirements to shape the way technologies are changing diagnostics in this space. Very exciting. The last session was really looking at some of the gaps in vector-borne diseases, and in particular the febrile illnesses, very close to our heart because we run the World Dengue Day campaign, asking the UN and WHO to ratify a World Dengue Day. One of the most underreported diseases in Africa today is dengue, so some pressing needs covered by the digital approach, and brand new models opening up in terms of financing, manufacturing, and kind of filling the gaps in terms of the gaps for diagnostics there using the digital approach. So really interesting session, and that brings us very neatly into our final session, which is the Diagnostics Beyond Diagnosis session, evaluation, surveillance, monitoring, touch points outside of the traditional kind of focus that we have. So we're very honored to have on this panel Dr. Katie Gass, the Director of Research at the Task Force for Global Health at the NTD Support Center in the USA. We have also Dr. Francis Krampa from the West African Center for Cell Biology and Infectious Pathogens from the University of Ghana. Dr. Seth Inzaule, speaking from the African Center for Disease Control and Prevention in Addis Ababa, beautiful Addis Ababa in Ethiopia. We're looking at genomic-informed pathogen surveillance in Africa, a new wave in terms of opportunities and challenges. We also got Dr. Anthony Sifuna from the Masinde Muliro University of Science and Technology in Kenya, speaking about the better need for diagnostics for environmental pathogen detection, a new front. And then Darlington Akogo speaking is the director of minoHealth. It's an AI lab in artificial intelligence lab in Ghana, speaking about the value and application of data from digital diagnostics. So a very interesting and wide-ranging panel. I think that's enough from me. I think it's time to start the panel. So I think I'd like to a very warm welcome to Dr. Katie Gass. Thank you for joining us, Dr. Gass. And I think I'll back out and I'll leave it to you. So over to you. All right. Thank you.
Great. Well, thank you. I'd like to start off by just thanking ISNTD for hosting this great event and for inviting me to speak here today. So I'm going to be talking about the need to rethink neglected tropical disease diagnostics if we want to achieve elimination. So when it comes to the preventative chemotherapy-treated NTDs, the diagnostic tools that have served us well for mapping and monitoring the great progress of the past decade are unfortunately insufficient to take these global programs through the finish line of elimination. And in fact, we need a complete reboot to the way that we've been thinking about diagnostics. And this is because the testing needs for NTDs are unique. Unlike large disease programs like TB or HIV, the goal of testing is not to make an individual diagnosis, but NTD testing is used to make a public health decision. And for the PC NTDs, these decisions are made by applying a diagnostic test in the context of a population-based survey to measure a WHO-specified threshold for the specific disease. And so for the elimination endgame, the NTDs need tests that are fit for purpose. And this requires us to make 4 key changes in the way that we think about, develop, and deploy diagnostic tests for NTDs. And the 4 changes I'm going to talk about briefly today are the recognition that specificity is paramount, the need to consider the context in which the tests will be used, a willingness to abandon the single test paradigm, and being able to adapt our decision rules to reflect test performance. Now, when it comes to disease elimination and measuring a rare event, it feels like common sense that one would need a highly sensitive test to detect those needles in a haystack. But it turns out that for the NTDs, it's specificity that determines a test's utility for endgame decision-making. And this is because population-based decision-making requires different thinking. So for example, let's take a typical program strategy for stopping mass drug administration. And so you would test a sample of the population and then compare the observed prevalence against a target threshold. And based on where that observed prevalence falls, decide if mass treatment should continue or if elimination has been reached. Now, the key here is this observed prevalence will be comprised of a proportion of true positives and false positives. And as disease approaches elimination, the proportion of true positives will decrease, while the proportion of false positives will increase, which makes it harder to interpret the observed prevalence. So to understand why specificity is key, let's take a look at the impact of test performance when prevalence is low. Specifically, what is the impact of sensitivity and specificity on the negative predictive value? And just for a quick Epidemiology 101 refresher, NPV, that's the probability that someone testing negative is uninfected. So we have 2 graphs here, and on the y-axis of both the graphs is the negative predictive value. And on the left, you can see I'm varying the sensitivity from 50% to 100%. And on the right, varying specificity from 50% to 100%. And really, the key takeaway here is that increasing sensitivity or specificity has very little impact on the negative predictive value when prevalence is low. And this makes sense because almost everybody in the population is, in fact, truly negative. But what happens when we look at the positive predictive value? And again, that's the probability that someone testing positive is infected. And here again, we have 2 graphs. This time, it's the positive predictive value that is on the y-axis. So let's focus on the graph on the left. This is looking at sensitivity. And you can see that as sensitivity increases, there's little change to the positive predictive value, as evident by the relatively flat lines you see. And in fact, it is prevalence and not sensitivity that has the greatest impact on the positive predictive value. But that positive predictive value remains pretty low. Now let's look at the right-hand side where we're varying specificity. If you look at that graph, you can see that the PPV increases almost exponentially with specificity. But it's not until you reach at least 95% specificity that you start to get a positive predictive value that approaches even 50%. So the key takeaway here is that specificity really is the main driver of your positive predictive value when the prevalence is low, and that minor changes in your specificity can dramatically impact your interpretation. So my second point is that we need to consider the monitoring and evaluation tool when developing new tests. And to illustrate this, let's take a hypothetical test and suppose it is 95% sensitive and 99% specific. So what is the probability that one uninfected person tests negative? This is just the definition of specificity, so it would be 99%. But what we really care about for NTDs is what happens when we test a population. So if we do a larger survey in order to estimate prevalence, how would this test impact our results? So what is the probability that 1,500 uninfected people test negative? And this is actually similar to the sample size that is used for a transmission assessment survey to stop mass drug administration for lymphatic filariasis. So while each uninfected person has a 99% chance of testing negative, the likelihood that all 1,500 people test negative is 99 to the 1,500th power, which is essentially 0. So even if the entire population were uninfected, with a test that has this accuracy, you wouldn't see 0. So how many false positives out of 1,500 would you expect? Well, the distribution of expected false positives is there on the left. And as you might guess, with 99% specificity and a sample size of 1,500, the most likely number is 15, which you can see from that graph. But more importantly, it would not be uncommon to observe 18, 19, or 20 false positives. And in fact, it's not until you see 22 or more false positives that you can start to rule out the likelihood that this is a chance finding. So coming back to the lymphatic filariasis analogy, for a sample size of 1,500, the critical cutoff for measuring transmission at a 2% threshold is 18. So even if elimination has been achieved and everybody is truly negative in the population, there is still a 20% chance that you would observe more than 18 positive results by chance alone. So clearly a test that is 99% specific is not sufficient for measuring a 1% or even a 2% threshold with some statistical confidence. And so this having inadequate specificity could prevent programs from demonstrating that elimination has been reached. So what can we do? Well, one option is to move away from this reliance on a single test. And let me start by giving an example of sequential testing, which has been used by a variety of public health programs, notably in the HIV world. So we start by testing everybody in your survey population with a first test, and this could be a rapid point of care test. And then only those who test negative by the first test would receive the second confirmatory test. And individuals who test positive by both tests are considered the true positives. And one could pick your test strategically so that the first one maximizes sensitivity, the second one maximizes specificity. And it can be shown that this approach can lead to a net specificity that is greater than either test alone. Now, alternatively, instead of 2 tests, one could consider 2 markers. So for example, a diagnostic that measures 2 different antibodies for the same disease. This is akin to parallel testing. And the detection of 2 or more markers for a single disease on one test gives the user an options for how they interpret the results. So one could interpret the results in a way that maximizes sensitivity by saying that a positive signal for either antibody means that the individual tested positive. Or you could choose to maximize specificity by requiring that both antibodies be present on the test in order for an individual to be considered positive. So consequently, one test could potentially serve multiple program needs. So the key takeaway here is that using 2 or more tests or markers in a sequential or parallel strategy can increase the specificity of the diagnostic approach beyond that of either test alone. And consequently, this can help to relieve some of the high specificity demands that are placed on a single test when we're trying to measure a low prevalence of elimination. But finally, it's clear that no diagnostic test will ever be perfect, and we don't want to let perfect be the enemy of the good. So when epidemiologists design a population-based survey to measure a threshold, the following 4 parameters are commonly considered. So that's sample size, the threshold, type 1 error, and power. And in the context of NTD elimination, we can think of power as the likelihood of identifying correctly that elimination has been achieved, whereas type 1 error is the risk of prematurely concluding that elimination has been achieved when in fact it has not. And so we can think of these as levers that can be dialed up or dialed down. And moving one, like realigning the threshold, will impact your other parameters. So for any survey tool, it's a balancing act of how to set these. But historically, the NTD programs have rarely taken into consideration test performance when designing these tools, which is akin to assuming you have a perfect test. And we know that that is, of course, not the reality. And so it's important that we modify these survey parameters to reflect the test performance. So for example, if a test is less than 100% sensitive, this can be accommodated by increasing the sample size. Similarly, if a test is less than 100% specific, the threshold for decision-making can be increased to incorporate the proportion of false positives, or you could decrease the level of acceptable power. So the main point here is that moving forward, disease elimination programs should consider adapting their M&E decision rules to account for test performance. So to conclude, the ability of the PC-NTD programs to stop mass treatment and have confidence that elimination is being maintained hinges upon the availability of diagnostic tests that are fit for purpose. And such tests will need to be highly specific to measure the low prevalence thresholds indicative of elimination, and just how specific will depend on the target threshold and sampling strategy being employed by the M&E tool. And if those specificity requirements are prohibitively high, then test developers should consider creative solutions, like combining tests serially in the case of a confirmatory assay, or in parallel by creating a multiplex test. And this can result in significant gains to net specificity. And then finally, it's important to recognize that no test will be perfect. And it's imperative that the M&E decision rules be adapted to reflect test performance in the field. And if we take these steps, I believe it is possible to have a diagnostic strategy that can get us through the elimination endgame. And so with that, I want to thank the organizers once again. Thank you very much.
Thank you very, very much, Katie, for that. I mean, wonderful presentation, and in some parts speaking to the balances between individual risk and population benefit as one derives from the sensitivity and specificity of a test as part of an overall strategy working towards elimination. I thought it was a wonderful presentation. Different approach in terms of, we've been talking about access all the way through this, but this is from a different perspective and how this could impact the way tests are developed. So wonderful. We're already getting some questions coming through in terms of associating two markers and this type of thing. So I'm sure we'll feed those into the Q&A at the end, but thank you very much from us for that. That brings us very nicely to the next presenter in this Diagnostics Beyond Diagnosis session, the final session. It was a warm welcome to Dr. Francis Krampa from the West African Center for Cell Biology and Infectious Pathogens at the University of Ghana. Dr. Krampa will be speaking about why we need the next generation of point-of-care tests. Francis, if you could just hit your video button, if that's possible. There we go.
Yeah, that's possible.
Yeah, excellent. Nice to see you. Looking great. And I'm going to back out. I'll let you run your presentation. So over to you, Francis. A round of applause. Okay.
Yeah, thank you. Yeah, so I'm going to be highlighting why we need the next generation point-of-care tests. My name is Francis, and I am a postdoctoral fellow at the West African Center for Cell Biology of Infectious Pathogens in Ghana. So when we compile the total human health hazards, you would find out that majority of these are attributable to infectious diseases. If you look at where they are most prevalent, it's usually the low middle income countries, specifically sub-Saharan Africa. But you'd find lots of the healthcare facilities that are condensed in urban areas, whereas majority of the population live in rural areas. Close to about 60% of the population in sub-Saharan Africa living in rural areas, whereas just about 30 to 40% live in the urban areas. But you'd find close to 70% of the healthcare facilities with good laboratory facilities all condensed in the urban areas. So there's this huge divide. So when you seek healthcare, it will depend on where you are. Are you in an urban or in a rural area? So primary healthcare, if you're in an urban area, is within 1 to 12 hours away from you, whereas it could take up to 4 days to get access to primary healthcare. Should you require a reference laboratory, it can take you some additional 2 days if you are in an urban area, or as much as 5 days if you find yourself in a rural area. So for some unfortunate people who find themselves in really remote areas, the only access they get to diagnostics is when churches or certain corporate bodies visit their communities to have outreaches. That is the sole access to diagnostics that they come across. So I believe we've seen lots of the drawbacks of how we don't have access to diagnostic facilities in sub-Saharan Africa. But I will just put them into 3 main categories. First will be the access in itself. Next will be the quality issues. And the last will have to do with implementations. Poor implementation, like supply chain problems, and then the absence of training programs and standards, government standards that regulate laboratories for quality. So clinical laboratory diagnostics could be faced into 2 main groups. One, the under-resourced labs. What kind of research, what kind of diagnostics would they be doing compared to the resource labs? You find out that the under-resourced labs can run nothing on optical imaging techniques, molecular techniques, and serological techniques. The only option they have there when it comes to diagnostics is the use of RDTs based on immunochromatography. Compared to the resource labs, they can do any of these techniques from optical imaging, serology, molecular techniques. So, categorizing these into the various infrastructural deficiencies, you find the minimum to no labs, they have no reliable electricity, they don't have any cold storage, and they lack clean water. Compared to the labs with good infrastructure, they have all these facilities which they can run with normal regular diagnostics. Now, when it comes to the kind of samples that they can interrogate, moderate to advanced labs can work with venipunctures, like blood from venipuncture, etc., CSFs and sputum. Whereas the minimum to no labs, they only have access to only finger prick alone. So what kind of diagnostics will these be able to do in terms of elimination and then control? Now, the RDTs, which is commonly used, have they really bridged the gaps that they are in diagnostics? Well, it's a double answer. It's both yes and no. Yes, because you have now, access to point of care testing. However, they have variable analytical performances. So there's a need to move away and consider alternatives. Most promising is trying to use nucleic acid amplification techniques compared to pathogen protein detection and then serological tests, which are commonly used. Nucleic acid amplification techniques offers you the advantages of early detection of the parasite DNA. Therefore, just a day after infection or just after exposure, you'll be able to detect your pathogen. Whereas you'd have to wait for about maybe 5 or a couple more days before you start detecting your antigens or your antibodies based on how your body responds immunologically. Now, molecular testing offers certain intriguing advantages which are important in NDTs. These include the changing diagnostic landscape, which requires that you have transmission in low prevalence settings. These would require molecular tests. Next, you have multiple pathogen detection. They allow you to do multiplex systems. With the advent of NGS and extra, you can probe mutations in certain protein markers. You can also track the emergence of new pathogen strains and strata. Some of the strategies that these next generation point of care tests have been applying is the use of biosensing techniques, lab chips, which are based on like microfluidics platform. So with just a drop of blood, you can channel it through various forms to interact with as many targets as possible. These allow you to probe your markers in small volumes and multiplexing. Next to be your host markers, you could distinguish between similar infections. For instance, You could distinguish between dengue and then malaria, which usually tend to present with same symptomatic like presentations. Molecular diagnostics are on the increasing rise because they allow you to do drug traceability testing. You can detect mutations and as well as rapid identification of variant strains. Digital platforms, as we had throughout today's series, are really, really encouraging in terms of developing the next generation tests for point of care. They allow you to do geographical mapping of risk areas. They can provide information regarding the disease emergence and the spread and control, as well as communicability between labs. So, revisiting the initial drawbacks of some of these lack of facilities. How can these new technologies upcoming, how can these leverage on this and trying to improve diagnostics? One, looking at the lack of electricity, new technologies could develop equipment-free or slow rechargeable battery-powered devices to try to electricity. Next to be for labs that do not have anything on cold storage and temperature control, there could be lots of integration of test processes into fast sample-to-answer devices without the need of refrigeration, etc. For working in sterile conditions, we could embed disposable cartridges that contain reagents for tests. Because of the lack of trained personnel, new technologies need to focus on automation with minimum interaction with the sample process. We can also probe analytes in easy to obtain samples. So instead of blood, the new technologies should try to probe some analytes in like saliva or sweat or even swabs. Yeah, these would also encourage uptake of diagnostics. Turnaround time is actually a very good requirement for the new diagnostic kits. Footprint and cost. The high-end expensive equipment should be avoided, and complex chemistries as well should also be avoided. In terms of data storage, digital platforms for tracking and remote monitoring of patient records should actually be integrated into many of these new upcoming technologies. One of such technologies, as you have already heard, is the Laser Swing platform, which has been designed by collaborators from Imperial College, Dr. Panellists. This is a handheld molecular diagnostic tool, like a PCR kind of a thing. So instead of having a sophisticated lab where you need to have complex equipment to run PCR with electricity, this battery-powered device can just run your PCRs for you and you get your result as you would from a specialized facility. Now, compared to some RDTs and its mother real-time PCR, we can see the device is quite cheap and fulfills most of the criteria for the assured WHO criterion. So, in conclusion, closing the gaps in infectious disease surveillance and monitoring, and of course, which entities form a part, would require the development of simple, low-cost tests for use by first contact care providers. These also have to be multiplexed, paralleled, multi-analyte testing. They should also be capable of doing drug traceability tests. They should probe specimen in samples which are very easy to obtain. They should be at the point of care, and they should be highly sensitive molecular technologies that span the healthcare value chain. So, could we say that point of care would eventually replace laboratory clinical labs? The answer is no. But if you're able to provide all these facilities, you could widen access to as much as 48%, especially 45% of the African population. So I would like to acknowledge the Digital Diagnostics for Africa Network, who made it possible for me to give this talk. Thank you.
Thank you very much, Francis, for that. Some amazing insights there from your work. including the potential to extend access to 45% of the African population by using this point of care, this approach. Very interesting indeed. Some of the barriers you mentioned there, the cold storage, electricity, clean water, I'm sure we'll address those in the Q&A because they are real. And a lot of questions are already coming through from the audience itself. So thank you very much for that. That brings us to the next speaker.
Thank you, sir. This is Anthony Sifuna from Masinde Muliro University of Science and Technology in Kenya. So my presentation is on the need for better diagnostics for environmental pathogen detection. So you may realize that my colleagues have talked about pathogens in clinical settings, but I'll try and link this to this African situation, but in this time trying to look at the environmental situation in Africa. What we need to agree and realize is that the environment plays a very powerful role in transmission of diseases, or rather infectious diseases, within our context. Sorry, there's some interference, sir. Now, a number of environmental factors influence this spread of infections within communities in our African context. Now, one important aspect is water supply. So water supply and sanitation play a big role in this situation. And you realize that since Africa, quite a number of infrastructure are least developed, like the waste management facilities, we find that they are able to contaminate water bodies. And in the process, you find that the water the communities are using are already contaminated. So in this case, transmitting pathogens to the community or amongst the community members. Food is also an important aspect in transmission of pathogens within the environment, or as humans interact with the environment. And climate also plays an important role in these processes of transmission. So as you see, African countries, or the poor countries, are the ones which are most prone to climate, the elements of climate. So as we go through this climate change, so African countries are more prone to these interactions with the climate. And there are situations whereby this increase or changes in climate will lead towards increased pathogen transmission. So biodiversity, as it were, as human activities, even within the communities, these are poor communities, try to interact with the environment, getting resources from this environment, and in the process interfering with even these environments, and the process messing up with the biodiversity and the stability of these ecosystems, and the process with the people interacting with the environment, we find that these communities are quite prone to infections, and such as the case you see, cholera could be an important cause which with changes in climate can easily be transmitted among communities within the African community, African continent. Now, what are these infectious diseases that are inflicting these low and middle income countries, especially in Africa? So, as it were, generally, looking at the African situation, you find that there are numerous weaknesses within our socio-economic and political structures. And these weaknesses do provide a very good impetus to environmental factors, such that these influence a great deal of our burden of infectious disease within our populations. So, interestingly, since some of these factors are environmental, we find that the traditional health systems that are within the communities hardly manage this, and therefore diseases may be able to spread quite easily within these communities because there are weaknesses within the environmental aspect, because most of the health issues are within those traditional health systems, and therefore environmental aspects do very little in trying to manage the environmental aspects and trying to cut this connection within transmission of pathogens within communities as they interact. Now, this therefore calls for a need for strengthening surveillance within the environment, within these communities, or within Africa as a continent or nations within Africa, strengthening these capabilities in trying to strengthen our capability in surveillance and monitoring of infectious disease agents within our environment, so that we can be able to understand how this environment and the interaction between human and the environment and those different aspects can be able to minimize or cut those transmission pathways. Now, as I said, these countries generally lack quality research. They lack effective infrastructure, and as my colleague Francis did present, we realize how weak even the clinical setups in trying of diagnostics are. So when you look at environmental monitoring structures in Africa, they are much weaker than even those clinical setups. So there is need for those strengthening of that, those aspects of environmental monitoring, so that these pathogens can be monitored, and then probably those controlled aspects can also be brought into action. Now, as you can see, Africa is laden with numerous pathogens that are related to environmental or are environmentally determined. So the burden would be 40%, about 40% of this disease burden is related to environmental cases, environmental factors. So you can see how important the environment would play. And if we had we developed the diagnostics tools that can be able to link between the environment and the disease transmission, surveillance, and monitoring, and it will go a great deal in trying to minimize some of this transmission and the cutting of the spread of these infectious diseases within sub-Saharan Africa. So as you can see, some of these, the dengue, the cholera, chikungunya, Rift Valley fever, all these infections are important, but they are also related to environmental aspects, whether in terms of contaminated water, they could be vector transmitted. So quite a myriad of different factors which may be involved. Now, looking at the current technologies that are employed in monitoring environmental pathogens, locally or in many setups in Africa, we find that one of the most important, or which is currently in use broadly, is this culture and microscopy technique. Now, it's a good technique. In fact, in most cases, it's the gold standard confirmation methodology to be employed. But it has quite a number of limitations, as it were. So you need a lab space, you need consumables, you need time to detect and make decisions. It takes time to do all this. You need personnel who are trained in trying to interpret those results, because it's more of manual interpretation of results. So you find that in African situations or in sub-Saharan Africa, you find that those are there are weaknesses in that aspect, because you need quite infrastructure and personnel to have this working for them. Now, the other aspect is techniques that can be used are indicator organisms, like this fecal indicator bacteria. So these are mostly in drinking water, agriculture, recreational. So these ones will definitely, one of the most important aspects is that although the bacterial indicators are easier to run out, but their correlation with either disease spread and also the other pathogens by pathogenic viruses or other microbes like viruses are basically not very well linked. So explaining some of the outbreaks which are related to environmental may be a bit difficult in this case if you are to use these techniques in trying to understand. Now, microbial source tracking, quite an interesting approach that has been tried in many setups, in developed countries, that is, where you are trying to relate contamination to water body contamination. But you need to develop a library or a database that you can be able to use these outcomes to be able to relate with what is happening in the environment and probably contamination within the water bodies, and then the transmission of pathogens through this environment. There are other tools like the immunoassay techniques. So these are good for bacteria, viruses, that is microbes, but they are less sensitive to some extent. They are time consuming. The antibodies may not be very stable when you are, because I'll be talking about some of these environments that you are working with these kind of technologies. PCR technique is good, can be able to amplify DNA, quite sensitive, but then the conventional type of PCR has challenges in that you are not able to tell the viable versus non-viable pathogens within the environment. So although you may be able to detect this pathogen within the environment, but you see you are not able to tell, is it viable so that you can be able to explain the spread, or is just the presence there, or it's not viable, that it's there, but then it's not causing any disease. So you are not able to relate that with the disease. We have also this real-time PCR, which is able now to handle this problem of viable vis-a-vis non-viable detections. So this is a good tool for amplification of DNA and trying to understand. You're able to enumerate and see how if you have viable or non-viable strains because of the enumeration capability of this tool. But then the challenges would be probably false positives and also the pathogens being detected in these new pathogens which are emerging. So you find that the technique may not be able to detect in that context, because you have to develop new tools or new markers for those new emerging pathogens. You have biosensors. These are also good tools, very sensitive, portable, probably very good for Africa, as it were, in the context of the situations in Africa, and as have been emphasized by, for example, Francis. But it depends with the type, actually, the type of the biosensor that you are deploying in this field. Lastly, we have the molecular detection methods, which also have been emphasized a lot with Francis. And these are my nucleic acid-based assays and DNA probes. So they are good. They are able to give epidemiological and taxonomic data, which can be very useful in epidemiological studies. So the only problem will also depend with the specificity of the genus in some species, and also strains in the different cases of these microbes. So there are those variations within the different microbes that could also influence how the level of detection and outcome for these findings, as it were. Now, why do we need these diagnostic tools in sub-Saharan Africa or in Africa as in general? Now, developing these tools to detect pathogens are quite important and will be able to help us understand quite a number of issues within our environment. Like, for example, what are the environmental drivers and determinants of these infectious diseases within the communities? Yeah. So at least we are able to understand what are drivers and what are these determinants. Again, we are able to understand vector control and disease prevention approaches that could be working, what could not be working in this case. So they will be quite good in even quality, trying to understand how our operations are working. We can also use these technologies in trying to map up geographical spread of these pathogens or disease within the environment, so that we understand this environment as and the spread of these pathogens within these environments. Now, determination of whether the intervention, as I alluded to this earlier, the intervention of these pathogens towards this pathogen spread and transmission are working. Do they need to be scaled up? Do they need to be scaled down? Do we need to change track? So these are important things or important questions that one, as we think into trying to get into the environment and understanding how the environment and the disease pathogens transmission works or interact. I think these are pertinent questions that need answers. And as we develop tools towards this, I think that serves to make us understand better these aspects of the environment and the pathogen transmission. It also helps us sustain a successful program if it's aimed at controlling these pathogens within the environment. So if we have good diagnostic tools, then at least we can be able to understand and sustain some of these interventions that are aimed towards controlling this pathogen and the transmission. Introduction of identification of novel emerging, as you know, like now we have the COVID and many other new emerging antibiotic resistant strains emerging within our environment. So these techniques can also be very useful in trying to understand what is happening, what is new, what new pathogens, what new threats are emerging within the pathogens that could be circulating within our environment. So that's an important. And as this wastewater-based epidemiology concept developed by some is a good tool whereby by just monitoring the environment, wastewater, you're able to tell quite a number of aspects that are important within people are exposed to pathogens, they're exposed to resistant genes, they're exposed to pharmaceuticals and related other, all those aspects. You're able to monitor these in the environment, and then you can also relate them to population size and many other factors, flow rates within these wastes, the daily loads. And we're able now to anticipate, even determine the prevalences, and that may be related within with this pathogen within those environments. So there is a lot of information which moving into diagnostics, and we move into the environment, that we can be able to dig out as we look, we try to look for these pathogens, understand how they interact with the environment, and see the best way to control them. So lastly, what is useful to us, or what do we need in trying to understand, or to be able to understand the environment and the pathogen relationships within our context here in Africa? So there are these emerging developments that may be useful for us as we try to develop tools towards detection of pathogens in our environment. So one could be these aspects of new developments in electronic surveillance systems, where information is related and transmitted within different aspects of from the source to probably a national control center somewhere, which does put together the data and try. So you need tools that are able to, or are amenable to such like new developments, new developments which can be able to link, use cloud, use telephone, mobile telephone technology, so that transmit these results to central centers where this information can then be interpreted and then be useful or used by governments. So one of such a technique or tool that is being developed by the Imperial College, this is the Less-Wing digital platform. I think can serve very good when currently is in use in clinical diagnostics, but it can also be tried out in environmental situations, and we try to see how it works. So this would allow for rapid problem identification and also action being taken up. So this tool also needs, these tools need to be rapid pathogen detection methods, rapid turnaround within, for example, 30 minutes, within 25 minutes, such that results can come out and actions can be taken up very fast. We are talking of fields in Africa which are remote. There is a lot of dust. So these field situations where you get a tool, get to next to the river, get to the forests somewhere and try to get samples, analyze them in the field, put them onto mobile phone and transmit them to a central point somewhere. And this will try to solve quite a number of issues that, or challenges that are present in Africa. So deployment of low technological environments. We are looking at a situation whereby you don't have laboratories within the field. You don't have reliable electricity. So we need technologies that can be, may not require these complex laboratory buildings, do not necessarily need electricity. Probably you can be able to connect them to solar powered technologies, and in the long run end up with getting, running the machines, and then you're able to generate the information. Exploit the data, that is bioinformatics, which is a field that is very useful now, very good in terms of tracking disease outbreaks, and also virulence or pathogenicity of these diseases. So in linking these these technologies with such like emerging fields like bioinformatics would really add great value to these new technologies. Now, lastly is the aspect of costs. So we need cheap but reliable, cheap but reliable detection technologies that can be used in a remote and rural setup. So this basically what I use for reference, and then I'm quite grateful to the Digital Africa, Digital Diagnostic for Africa network, which brings together we as scientists in Africa and the world generally to try and see how we can be able to develop tools that can be useful for the next generation of tools that can be useful for Africa. I'm grateful also for having been hosted on this conference. Thank you.
Thank you very, very much, Anthony, for that. A really new kind of touch point that you just started talking about in terms of the environmental pathogen monitoring. Very interesting, because the timing of this right now with the US rejoining the Paris Accords, the structural determinants of poverty being imagined by using migration, drought, weather patterns, climate change indicators into the new kind of definition of poverty, and these are diseases of poverty. So I do wonder, maybe this environmental touch point is really going to catalyze further movement for diagnostics at a government level, which is what's needed essentially, whether that's the financing, whether that's the political will to open up areas and further develop diagnostics per country. I think this might well be the catalyst, the touchstone for that. So thank you very much for that. Very robust and comprehensive presentation. In the interim, I've just seen that Dr. Katie Gass, thank you very, very much, because you've gone about answering some of the questions that have been popping up as we're going along. So we really do appreciate that. I'm sure the people in the audience would appreciate that as well. But that was a fantastic presentation. Thank you, Anthony, for that. I think it might be going back to Dr. Seth Inzaule at the African Centers for Disease Control and Prevention in Addis Ababa. Seth, can you hear us?
Yes, I can.
Okay, perfect. So I'll back out and over to you in terms of genomic informed pathogen surveillance in Africa, opportunities and challenges. Over to you.
Thanks, Cameron and ISNTD, for giving us this opportunity to present a talk on our recently published article, which was looking at genomic-informed pathogen surveillance in Africa, in particular focusing on opportunities and challenges. Infectious diseases pose a significant threat in Africa, accounting for up to 227 million years of healthy life lost every year, and this translating to about $800 billion US in loss in productivity every year. And apart from the endemic infectious diseases, the continent also faces the threat of emerging and re-emerging infections, which appear to be occurring after every 10 years, with chikungunya, for example, being first detected in Tanzania in the 50s, Marburg hemorrhagic fever in the 60s, Ebola virus in the 70s, HIV/AIDS in the 80s, and more recently, the COVID-19 in the 2020s. We have seen this slide before, but here we just want to show what was happening in the continent between January to August 2020. And overall, it's estimated that about 140 outbreaks of diseases occur in the continent every year. And because of this, there's a need for a new public health order to tackle infectious disease threats, and one that is resilient to adapt and to cope with the 21st century disease threats. And this was based on what was shared in the commentary by Dr. John and Sophonis. The new public health order also has to adapt emerging technologies that have been shown to revolutionize public health surveillance and outbreak response in other continents, for example, digital epidemiology and pathogen genomics. And compared to other technologies or the traditional diagnostic methods, pathogen genomics has a better precision, allowing for more precise outbreak detection, investigation, and response, as well as targeted interventions to interrupt transmissions. It's also more sensitive, allowing for early detection of emerging pathogens, as well as drug resistance variants, as well as vaccine escape variants. It also allows for more efficient detection and characterization of pathogens, and it also allows for discovery of vaccines, diagnostics, as well as drug designs. Pathogen genomics overall has a wide application in a wide spectrum of disease surveillance in Africa, ranging from diagnosis, surveillance, monitoring vaccine efficacy, supporting outbreak detection and response, in also supporting transmission dynamics and identifying potential pathogen reservoirs. And due to these, various global guidelines, in particular WHO guidelines, recommend its use for surveillance of different pathogens, for example, in malaria surveillance, in antimicrobial resistance surveillance, in TB drug resistance, as well as HIV drug resistance, in foodborne disease surveillance, and also in the surveillance of vaccine-preventable diseases. It's also worth noting that this tool is continually being used in the continent with various exemplars. For example, it was used in the 2014 to 2016 Ebola epidemic in West Africa to assess for transmission dynamics, and also in the recent Ebola virus outbreak in DRC, also for assessing transmission dynamics of Lassa fever virus in Nigeria in 2018. And more recently, it has been used to detect the emergence and spread of the new variants of SARS-CoV-2 in South Africa. And actually, it's not only in South Africa, but as you look in this map, a number of countries are widely adopting this tool to be able to monitor the emerging variants of SARS-CoV-2, which have been shown to be more transmissible and potentially accounting for the recent second wave that we are observing. But there are a number of challenges that hinders the wide use of pathogen genomics in the continent. From a survey that we did in the continent, we observed that we have about 206 next generation sequencers. However, up to 80% of these is in non-public health institutions, and 71% of all capacity is in 5 countries, with 38% of these being in South Africa. In addition, there's a lack of continental policies and guidelines. There's inadequate technical workforce. There's also limited capacity to support translation for public health decision making. Some of the solutions for which we proposed include creating enabling mechanisms, for example, developing policies and standards to guide good practices in the generation, sharing and use of genomic data, also advocating for price reductions for next generation sequences and reagents, also supporting method standardization. A second is in capacity building, that is creating systems that can be able to support the training of skilled workforce. And these include wet lab scientists, service bioinformaticians, as well as public health practitioners. Third is a community of practice who can be able to provide scientific, technical, and public health guidance, as well as the sharing of best practices. As well, fourth is on capacity building on infrastructure and network. And lastly is creating a system for leadership and coordination of all these activities in the continent. Sorry, the slide doesn't appear well, but what we are proposing for capacity building in particular is we propose that there's need to build capacity for multi-pathogen sequencing core facilities rather than the silos, building silo capacity in the different disease control programs. We also propose the build-up of a Pan-African network of pathogen genomic laboratories, and we propose to do this using the pyramidal structure that is widely commonly used in the different WHO disease control program networks. And at the base, we have the national disease control, and we have the national pathogen genomic laboratories, whose main function is to support the country's pathogen genomic activities. And then we have the regional pathogen genomic laboratories, which not only serve their countries, but also support countries in the region that do not have this capacity. And at the apex, we have specialized genomic centers, which serve to support on capacity building and training of the regional and national pathogen genomic laboratories, as well as supporting on quality assurance and research and innovation. We also propose that as we build this network and this capacity, there's need to also build up a quality assurance system, as well as data architecture systems to support the data archive, as well as analysis and subsequent use of the generated data. We also propose that as we build this capacity, there's need to ensure sustainability, and some of the aspects for which we propose to do this is incorporating genomic-based surveillance into national strategic plans for various pathogens as a means to advocate for resources. Also creating sustainability plans jointly with all disease control programs in the country, as well as and their donor partners. Third, integrating training into local curriculums for biomedical scientists and public health specialists. Fourth, institutionalizing pathogen genomics as part of routine surveillance strategy, as well as outbreak response. And lastly, advocating for price reductions for the NGS equipment and reagents, as well as better technical support from the manufacturers of these equipment. And Africa CDC has been working on this. In 2019, it created the Institute of Pathogen Genomics, whose vision is to integrate pathogen genomics and bioinformatics into public health surveillance, outbreak investigations, and improve disease control and prevention in the continent. And it has 5 cross-cutting strategic priorities, which goes in hand with the solutions that we have proposed, that is building, enabling mechanisms, policies, and guidelines in the continent to support these, the creation of the network, which can be shared across different countries, capacity building in terms of workforce development, building data systems, as well as supporting the implementation of public health priority use cases. And overall, the Institute aims to achieve, to support countries to be able to rapid and timely respond to infectious disease threats in the continent. And more recently, last year in October, jointly with partners, Africa CDC launched the Africa Pathogen Genomics Initiative with the purpose of strengthening laboratory networks and surveillance systems. And again, this initiative has 5 key components, which is in line with what we have discussed, but just to focus on number 1, which is to strengthen the Africa CDC Institute of Pathogen Genomics to carry its mandate in leadership, coordination, and resource mobilization, creating continental policies and guidelines, and also creating the community of practice and technical working groups around these. Just to mention that for number 4, the build-up of the Next Generation Sequencing Academy, this which is going to be tasked with workforce development in what we have discussed before, and also supporting the implementation of high-impact genomic use cases. This work is already ongoing, and currently we are supporting more than 20 national public health institutes, capacitating them with next-generation sequencers and data systems. And overall, we are trying to create a continental network of pathogen genomics institutes, and as well as bioinformatics. And we are doing this along the lines of the Africa CDC Regional Integrated Surveillance Laboratory Network. And so we have about 5 ResolNet structures, one in North Africa, Eastern Africa, Western Africa, Central Africa, and Southern Africa, where we intend that we're going to have at least regional pathogen genomic laboratories in these different regions. as well as various national public health, national pathogen genomic laboratories. Overall, the initiative aims to strengthen the prevention, preparedness, and response to emerging and re-emerging diseases. Second, to improve disease surveillance to guide the control and elimination of neglected tropical diseases and endemic diseases. Third, to prevent and combat antimicrobial resistance. And lastly, to catalyze research and innovations. Thank you.
Thank you very, very much, Seth, for that amazing vision from the CDC in terms of the plan that you've outlined there. I'm very excited to see that, and I'm sure you're going to get a lot of people coming to you. We're already getting questions from Dr. Ikram Ghazani from the Tunisian Institute of Pasteur in Tunis, asking how can we join the Pan-African Network of Pathogen Genomics Labs, as you've just outlined. So I'm sure you're going to get a lot of feedback from people in the audience. A wonderful presentation. Thank you very, very much for that. Much appreciated. It was worth waiting for. I think that brings us to the last speaker for this session and the end of D3, actually. We thought we'd leave this with the kind of future opening up in terms of digital diagnostics. And so value and application of data from digital diagnostics by Mr. Darlington Akogo, the director of minoHealth AI Labs based in Ghana. Darlington, are you there? Oh, perfect. Brilliant. Excellent. I'm going to give you a round of applause to start with. You're the last speaker we've got for the 2 days. I'm just going to hand it over to you. So over to you, Darlington.
Okay, thank you. So I'm going to share my screen now. Okay.
It might help if you run it in. Yeah, perfect.
Okay. Yeah. So my name is Darlington Akogo. I'm the founder and executive director of minoHealth AI Labs. So at minoHealth, what we basically have been up to is that we focus on developing AI and then data science solutions for healthcare, with a focus across diagnostics, forecasts, and prognostics, and even studying things like immunology studies and so forth. So we've been applying this to a number of conditions. So we have breast cancer, we have thoracic conditions. We'll get into a bit of them in a few slides later. But then one key thing we also do, apart from developing AI solution, is that we work with the United Nations. So the ITU, this is the International Telecommunication Union, as well as World Health Organization, towards developing global standards and regulations to guide the space of AI in healthcare. So I'm lucky enough to also be the lead of the topic group on AI for radiology, where together with a team of experts across the globe, we work on developing standards that would help in not only building AI systems, but also testing them. So making sure they go through similar level of rigorous tests that other things like medicines, vaccines, and even medical devices go through before they are approved in healthcare. So it will be appropriate to start from the point of defining what AI is, but then for our interest, we'll talk more about machine learning. So machine learning is a type of AI. Generally, if you want to define AI, it's simply trying to give machines human-like abilities. And with machine learning, we are still trying to do that. The only difference is that we are focused on using statistical methods. So using statistical methods that are able to learn from data to then perform a certain task on their own. So basically, you have a lot of experts in this conference that have spoken a lot of expertise, different domains. If we can collect data on them, we can have AI system learn from that data to then perform certain tasks. So that is basically the whole point of AI, and then everything there is to know about it. So practically, this is what it might sometimes look like. So These are from some of the systems we've developed. We've applied AI to a number of conditions, like I mentioned. So sometimes we are dealing with medical images. So AI systems that are able to look at medical images and then detect thoracic conditions. And then they're able to analyze it and tell you whether specific conditions like pneumonia, fibrosis, hernia are present, or they can look at mammograms and then tell you if a patient has breast cancer or not. But then also you have for conditions like tuberculosis too as well. You can look at data. In this case, you can look at medical images, chest x-rays, to be able to determine if there are any damages that are caused by tuberculosis. So this is actually a project we did somewhere last year. We had a hackathon that we ran across Africa, and we had so many participants that developed AI solutions for this. One project we also had with WAGBIP, so France's organization, so the West African Center for Cell Biology of Infectious Pathogens, was that we developed AI systems that were able to then look at antibodies and cytokines to be able to differentiate between those who had low and then high immunity towards malaria. And the goal was that we wanted to see what sort of features, what sort of attributes are responsible for that difference. And this will better help us to be able to then develop responses in the form of, say, vaccines towards malaria. So this was one research we also did 2019, 2020. With the Digital Diagnostics for Africa Network, my colleagues have spoken a lot about it, but we have one work package that is focused on data. And what we've been doing specifically with that work package is we've been looking at what are the potential and opportunities when it comes to data? What are the solutions that could be developed, especially when you're looking at things like molecular diagnostics with platforms like Lacewing? What are the pitfalls? What are the challenges? What are the necessary ethical and regulatory considerations that need to be put in place if we want to deploy this digital molecular diagnostic solutions? So to talk about one possible opportunity and solution is if you are able to digitize data from your test, if you are able to then have data, even if it's as simplistic as positive or negative, and then you have a timestamp on it, and then you geo-tag. So if you're able to tell exactly what day, time you took that test of a certain patient, and then what is the location of that patient, you are able to then generate what is called time series data. So you're able to plot it to see the total number of cases within a population. As we've seen with COVID-19, you're able to plot this across time. The interesting thing is that once you have that time series data, you can then do time series forecasting. So not only would you be able to accurately represent what is happening now, you can forecast what will happen few days from now, few weeks or few months from now. So that is one of the interesting things that we are able to do in data science and then artificial intelligence. So there are a number of algorithms that we use to be able to then do this. So it looks something like this. You have the confirmed cases, which are in orange, and then you have the predicted cases of what things are going to look like for whichever infectious disease you're trying to then forecast. So apart from that, once you also have that data, you can truly get a map of how the disease is then spreading. So we did this in the early days of COVID-19 in Africa. We mapped it and then we looked at the data. So for every single day since the first case was recorded in Africa, we're able to track it, build this tracker, and then see the changes over time across the different African countries. So I'm going to let this play for a few seconds. And the interesting thing about this approach is it's agnostic. So if you are looking at neglected tropical diseases, you can do this. If you're looking at something like COVID-19 malaria, you can still use most of the techniques that I've just described. Okay. Yeah. So yes, to just wrap up this, there are a lot of possibilities when it comes to data. This is applicable to neglected tropical diseases, malaria, so many conditions. So once you have that data, you can actually use it to automate and then develop digital diagnostic systems, or you can use that data to then develop multiple things when it comes to disease surveillance, modeling, and then even forecast what is going to happen. You can use that data to better understand immunology, help you towards drug discovery, vaccine development. The possibilities are endless. Due to shortage of time, I didn't want to go into ethics and then regulatory consideration, but it's important. As much as the only analogy I'll probably use is Facebook. So we all realize now, especially that with the amount of data that a platform like Facebook has collected, it can become detrimental if things don't go accordingly. So just imagine the same thing for healthcare. It could be worse. So as you are digitizing a lot of processes and collecting data, realizing the power of that data and realizing that you need to do things and ensure privacy, security, data protection is very, very essential as we keep digitizing and then heading towards this possible future of healthcare. Thank you. So as my colleagues also did, I'm very happy to be part of the Digital Diagnostics for Africa Network, working with brilliant scientists across Africa and the UK, across various institutions. It's been really exciting work. Thank you.
Thank you very, very much, Darlington. What an amazing presentation. AI and the whole impact of that to this sector, this area of NTDs. We covered it slightly in a Connect session that we did a few weeks ago, looking at digital pathology and AI in Diagnostics. And that gave a lot of areas where different players, different actors could come together. And I'm definitely going to send you an introduction email with you, Aubrey, and this whole Digital Diagnostics for Africa consortium to the people at Johnson & Johnson who are working on digital histopathologies and AI. A lot of questions coming through for the AI. So Juliet Chami from Cambridge is asking for minoHealth, could you share with us how you are incorporating local knowledge to improve or validate machine learning models? We've got, and I'll send all these questions out in a second, we're getting a lot of how to put this, individualized questions. And I know, Dr. Garst, Katie, you've really gone out of your and you really answered those specific questions. Because of the time involved, I think it might be worth if I could just call everybody to come back in terms of the panel, just hit your videos so that you're on. I just want to ask one question, which gives everybody the chance to answer, and then we'll try and bring in some of these other questions as well, because we've got such a varied field. And this was the last session. So, I mean, you made a point right at the beginning, Katie, which was, I find quite poignant, which was these are not individual diagnostics, but diagnosis, but we should look at this as a public health decision-making issue, right? And this whole work in terms of environmental pathogen detection and the whole concept around the massive vista that Seth had kind of laid out in terms of the Pan-African vision, all of this session, for me, really points us all towards the policy maker. And so my question to you, given that the WHO themselves are talking about moving to a country-owned model of country ownership, what would be, and then given some of the barriers, the financial incentive barriers, regulatory harmonization barriers, all of these things that are out there, given the various outputs from each of your presentations, what I'd like to ask, I'll get to the question in a second, is what would be your message to the policy people? I hope AI can predict some policy triggers for us because we're going to need them. What would be your message to the policy people what do they need to do? It sounds so exciting, diagnostics. It sounds so vital in all doing. Do we need to make better socioeconomic models in terms of case building for the policymakers? What would be your message? And I'm going to start with Katie first, if you don't mind.
That is the question, right? How do we continue to move this forward? I mean, we're living in a data-rich age, as we've seen from these presentations. And so for me, first and foremost, we need to think about how to incorporate all the information that is coming in. So that is the challenge for policymakers. It's to not narrow in on, blood-based tests, but look at the environmental information that's coming in and the vectors, the xenomonitoring, as others have pointed out. So I think being expansive in our thought process and decision making, be willing to consider multiple indicators to make decisions will be key moving forward.
Okay, that's a great answer, and I think you've summed it up really nicely in that sense that there is so much going on that perhaps the policy people, that strata, haven't actually caught up. They're still in the inertia of the old world, and this definitely is about the new world. So that's a great answer, Katie. I'd like to ask the same question. Really, I'll ask Anthony Sifuna, because of the environmental determinants of poverty and how that's changing the landscape in terms of how we actually view poverty. There's a Lancet commission on this a few weeks ago, looking at this as well. And I just wonder what your take is on that. What would you say to the policymakers? Why they need to look at diagnostics differently, why they need to engage differently, political will, financial capital. What would be your message? And that's to Anthony, Dr. Anthony Sifuna, please.
Yes, thank you. For me, I think I'll basically focus on the environmental aspects of this pathogen disease transmission. And my thinking is, if you are to look at first the world, like you put it, WHO, I think this is a weak aspect in terms of health aspects. The World Health Organization has not strengthened aspects of the environment in trying to strengthen mitigation aspects that they may want to deploy in trying to mitigate disease transmissions within human, as it were. So I think it's an aspect that we need to try and address from that level, resources being mobilized so that this aspect of transmission within and the monitoring of the environment is captured in policy documentations, because it is an emerging field and a key player in disease transmissions.
Yeah, I mean, that's a very, very good point, Anthony. So maybe the timing is now. The timing is right. We've had the US re-enter the Paris Accords. There's a lot more of a focus on the impact. You say it's an emergent field, but in things like dengue, as an example, the effect of climate change on vector transmission, vector ecology, disease distribution, because of that, is quite pronounced. It's quite detailed in terms of the research that's going on there. You're seeing these centers of planetary health crop up everywhere, and kind of convergence of disciplines. So maybe the time is now. Maybe we're moving from one health to total health when we include all these reimagining poverty. So go total health. That's a great answer there.
I like that, total health.
You heard it here first. But that's based on the excellent presentation, the way it's got everybody thinking. So that's a credit to yourselves. Seth, I think you're the easy target for the next part of that, because you're the CDC. You put such an amazing vision out there in terms of building capacity, the people. All of this alludes to policy. It all alludes to release of financial capital. what would be your messages? What would you say, Seth, from the CDC's position to the various governments and the policymakers out there? How do you need to engage with diagnostics? Over to you.
I think overall, like what you notice is, especially in the pathogen genomic space, there's still gaps in policies. And overall, how we can be able to use the genomic data. I know different agencies are trying to look at this space, but also and we also have noticed that even in countries, there's variability in the policies that can be able to guide the use of this data. And we are also trying to move to the space of cross-border disease control, joint disease control efforts. And with this, we think that we need better policies. And that's one of the key things for which Africa CDC is doing, to try to be able to develop continental policies, engage countries, get a buy-in in genomic data, how we can be able to use it to address the different disease challenges in the continent.
That's a fantastic answer, very diplomatic as well, I must say. Perhaps it's the inertia behind regulatory harmonization, or the lack of it, which you're seeing in terms of not being able to get more of a fractured kind of, how to put it, catch up in terms of policy across Africa. And I do wonder whether the data landscape is going to lend itself to a far more, how to put it, cohesive landscape onto which we can build harmonization processes, because data is that's what we're talking about here. Data that's going to be pooled and put into evidence bases, and maybe that's where we need to focus in terms of harmonization. So all the issues around data security, ethics, all of that are going to start coming into play, I think. So it's a very interesting answer and a very interesting development. I think also I wanted to ask that same question actually to you, Francis. You talked about the need for the next generation of point of care tests. What would you say, Francis, to the policymakers in Ghana, let's say, in terms of we need these tests? What do they need to do from your point of view to make this happen?
Well, my message to them is going to be very simple. I would say diagnostics need investment, and failure to invest, I mean, you are not giving your people the right healthcare.
So perhaps tying it into the UHC, the pull from the UHC backdrop that is actually,
and technology has caught up with that so much.
Yeah, the demand for healthcare, creating the demand for healthcare. So you're saying address the policymakers that you're failing the people. I don't want to get too political because I'll get pulled off, but that's kind of the essence of where you're going with that. Is that correct?
Precisely.
Yeah, with you with that, completely with you on that. So good luck to you with that. I think with this UHC pull, I think that's an automatic, not automatic, but it's an inevitable endpoint to which we're gravitating towards, I think, where the people themselves are demanding their right to healthcare. This could be an interesting stepping stone in revitalizing the entire way we imagine diagnostics and this sector to work. That's why we're so excited, and that's one of the reasons we had Darlington Akogo, because Darlington, I know you've just rejoined us there. There's no escape, don't worry. You had to answer the question. You, to us, represent a fascinating part of this new evolution. You know, young person, you've got out there, you've done your thing, and you've created a company, you're creating this kind of movement. What would you be saying as a young person who's, you know, achieved so much, who's pushing in a commercial direction, as well as, you know, generating evidence to back what you're doing? What would you be saying? And I hope it's you. It's not an AI avatar that we're speaking to, Darlington. I hope this is.
Oh, wait, that was directed. Oh, okay, yeah.
So what would you be saying? What would you say?
Just joined. Yeah. The question is about what will be the response, or what will be the advice to policymakers, right?
Yeah.
Okay. So I'll try to keep it brief. I think in context of what is happening with COVID-19, for example, which also could be applicable again to neglected tropical diseases will be that I think in Africa, for example, we are underutilizing the space of epidemiological modeling, or just broadly modeling, forecasting. I've seen government, I've seen policymakers make a number of decisions that, had they maybe modeled what would have happened if that decision was taken, things would have panned out differently. So certain things like in the context of COVID-19, should schools be open? Should the borders be open? Each of these decisions, you can actually model them based on the data you have, and then see possible scenarios and outcomes of it. But even more broadly than saying don't open schools, you can look at different scenarios. If you do open schools and you test out different ways, so should children be given masks? Should this happen? All of this could then help you prevent a number of things. So we are seeing the effect of people who do this and don't do this in real time across the globe, actually. So that is one thing. But also, I would say that it's important to have regulators step in and then put in certain key measures in place so that these technologies are not abused. So that is one thing I'm extremely, extremely worried of. I don't want a scenario. So we saw what happened with self-driving cars. I don't want a scenario like that in healthcare. If that happens, it will alarm people off, and no one will even want to use AI in healthcare anymore. So it's good to be early with and forward thinking with the regulations is extremely essential.
That's a very good answer, actually, Darlington, in terms of this the catch-up that the regulatory world has to do with the digital world. There is a gap appearing, and it needs to be resolved quickly for this to be effective. So I'm completely with you on that. I mean, that's a wonderful set of answers. I've got loads of questions coming through, but they're quite specific. You know, lots of thanks. Bonnie Webster from the Natural History Museum in London, talking about thanks, Seth, excellent and so important. Great to see this capacity being built in Africa. One problem that is becoming more and more difficult is the movement of samples between countries for analysis, and restrictions imposed, such as Nagoya. Has this impacted any of the work you presented? So I've asked that question. What I thought might be better is, if you're all okay with that, I could send you an introduction email with each other to perhaps continue that conversation. Because what I want to do is make sure we're engaging all the panel. I think that's a fairer, more equitable, in line with all the access kind of biases that we set up over the last 2 days. One interesting point, which is very interesting to me, is that the world economy is obviously realigning coming out of COVID. Some countries have got vaccinations at a certain level, some haven't. Whether that's down to political movement or that's down to some kind of, how to put it, it's just how it is. Some have, some don't. And so different types of alignment are occurring, different sectors, different economic alignments are occurring. I'm just wondering, is this the time now to put forward an argument that the digital economy, especially in Africa, this is the time to get involved, and this is the time, this is to the policymakers to re-examine the assets that they've got. When I say assets, we ran a hackathon a few years ago. We have a festival every year, Science Communication Festival, music, arts, apps, print. We give awards out. It's coming up at the end of March, actually. You're all welcome to it, to come to that. It's usually at the Wellcome Trust, but because we're going virtual this year. In any case, we had a hackathon for, we had a little bit of money and we gave out some prizes for a hackathon for dengue, right? We were shocked at the amount of entries we had. This is going back about 5 years now. And we were inundated. And what really struck me was that this is such a huge asset. The coders, the programmers that are out there, they just need direction. And perhaps the digital world, through this work with NTDs, will start providing more of a clearer pathway for kids that are involved in programming, kids that are involved in this kind of digital arts, the Jedis, just call them the Jedis. Maybe that's going to be a path out of this, which is actually going to end up redefining the way we view financial incentivization for the development of diagnostics. It's a totally new vista. And I think that's something that we're really going to pick up on this year as the International Society and try and open up in our ISNTD Connect sessions and try and further that debate. I think the time is now to do that. But I could go on. I'm not going to, don't worry. It's getting late. I know you're in different time zones as well. We've had a wonderful 2 days. What an amazing journey that was. We started with the Financial Times, Andrew Jack, talking about reimagining. He chaired the first panel on financial incentives, reimagining for drugs and for diagnostics. We went from there into access, redefining access and how that's impacting the R&D process with major funders, companies, academics, all involved. Wonderful day yesterday and a very interesting session on repurposing. And I wondered to myself how the digital revolution is going to impact that, because we had the US FDA on that, talking about the repository that they've made, a data repository that's taking information at an anthropological level, really, from the people themselves, anecdotal, and channeling that into an R&D process towards repurposing drugs for NTDs. So I wonder if the digital world could impact on that as well. We've had such an amazing day today. The WHO opened it, Essential Diagnostics, and the whole thing about getting countries to adopt and adapt this international EDL iterations for national use. So a lot of onus there on, again, the policymakers. Some fascinating work in Schisto in terms of modeling and the impact of that to the wider MDA community. And that's the thing we wanted to have in this 2 days, is to kind of show that when people think about NTDs, it's not necessarily the inertia that is there because of the great, amazing work that the mass drug administration programs have done. But I think now the comma is there in grammatical sense, and we're moving forward. Bonnie Reps is writing, thank you everyone for a very inspiring day. That's the right word, inspiring, inspirational. Lizette Van Lieshout from Leiden, great day, fantastic presentations, and very important discussions. So they're thanking us, we're thanking you, actually, so it's a thank fest. So it's like that. But that's enough rhetoric from me. Thank you very, very, very much from Marianne and myself here for joining us. I hope you can make our festival at the end of the month, end of March. We'll be giving out loads of prizes. Thank you very, very much, guys. Great conference. Thanks a lot. Yeah, peace out. Goodbye, everybody. Goodbye. Take care wherever you are. Keep safe. All right. Bye-bye.